A lot of people say the problem is that there's a gap between dev and ops. The dev team is separate from the ops team, and we should bring them closer together, and this will solve our adoption problem. The devs should wear pagers, and the ops people should write code, and together we'll have the perfect IT world. Now, this is great, but I would actually say the larger gap in every business is between the coders and the non-coders, between the tech side and the business side. So how many people here would say they work on the tech part of the business? Okay, and how many people say they work on the business side? Okay, this non-coders thing might be a little bit harder. So the problem is this gap, the largest challenge for IT is organizational change. This gap between tech and business and this communication gap that occurs really poses a challenge to adoption of new technologies. And like any good business presentation, I'm going to now have a slide with $signs, bullet points, and citing some important people. So I think we all know that cloud and IT is a very important issue for companies. Cloud spending is going to top $200 billion by 2020. That's a lot of money. So how do we make sure we're actually using that money correctly? If you're in tech, there's a lot of words you throw around: containers, Kubernetes, DevOps. But the problem is most of these words don't translate to the business side. The tech people are talking over here, and it doesn't make sense to the business people on the other side of the room. And so that's what this talk is about today. So Kubernetes for non-coders. And what we're going to be going through today is first, what are we actually dealing with? How do we get here? What is Kubernetes? And what comes next? All without a line of code. We'll see if it actually translates to the tech side. And so a little bit about me and why maybe I'm qualified to talk about non-coders. So if you can see here on the left, that's me with my 6th grade science fair project. I was a scientist. I got my undergraduate degree in biochemistry, worked with real mice, not computer mice. They bit me. I decided it wasn't so fun. So I left that field and went into bike racing for a little bit. After that, I went to grad school for social science. At no point along that journey did I work with code at all, so I don't have the code background, and I can't provide that for you today. But now, coming out of grad school, I'd gone from a hard science, where it's like guaranteed good job, to social science, and I was like, okay, well, it might be a little bit harder. How do I actually have a job now? So I was really excited when I got a job offer from LUDSA. I was like, first job, like really excited. They're like, okay. I was just happy to have a job. And they're like, what we actually do? And I was like, yeah, can you just tell me? And they're like, okay, we help companies do Kubernetes and cloud native technology. We do that through training, professional services, and our Kubernetes container engine to let people have Kubernetes in one click on any infrastructure. And I was like, great, this sounds like the perfect first job. Kubernetes, like super excited. What is this? Like definitely a Greek island. So I'm gonna be hanging out at the beach, like eating olives, sipping wine, tanning by the Mediterranean. This is the perfect first job. And then I got to like the other cloud native part, and I was a little bit more concerned about that one, like climate change, that type of stuff. I wasn't so sure if I was excited about cloud native, but Kubernetes still sounded really exciting. Then I did the actual logical step is Googling both of these, and the definitions I came up with is unfortunately not a Greek island. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. And so I was a little bit disappointed. I didn't really know what a lot of these words meant, but I was like, okay, cloud native, maybe I can do a little bit better there. And so got to a lot longer definitions. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds, containers, service meshes, microservices, immutable infrastructure. Declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably, with minimal toil. To say I was a little bit confused at this point is a little bit of an understatement. It's like, okay, well, how do I actually understand what I'm about to do? And so how do we translate all of this Kubernetes code into something that non-coders also understand? And so what is business code? Every business is basically premised on providing either a good or a service to their customers that provides value to them in a way that's either better, faster, or cheaper. So this is the code I'm going to be using for the rest of today. Better, faster, cheaper. Everything that we're going to talk about from here on is going to be tied back to better, faster, cheaper. And so we're going to start out with explaining Kubernetes. The first thing you want to do when you're talking to business people is like throw up a big, flashy, like cool internet tech company. And so we're going to say Google. And so Kubernetes actually came out of Google. It was basically premised very similar technology to how Google runs their IT infrastructure. So everybody on the business side is super excited now. They're like, oh, we're going to run our IT just like Google. Perfect. And if we dig a little bit deeper, the meaning of Kubernetes is actually Greek for helmsman or pilot, so running all of your containers, ships, stuff like that. And it's the root of the word governor and cybernetics, which is the study of communication and control. Okay, a little side note. So Ludsa is actually from Plattdeutsch, and it means harbor pilot. So we're kind of like the captain's captain. So we get to run all of the Kubernetes clusters. So side note about Ludsa. That's in case you're wondering where it's from. And so Kubernetes project stats. It's one of the fastest moving open source projects in history. Everybody's like, yeah, super excited, like really fast, like move fast, break things, right? Lots of stats you can see here. Kubernetes is the little red dot up and to the right. Like any good business thing, we want to see things going up and to the right. So great, Kubernetes is right on track. And like any business thing, we also need to talk about like the management. So Kubernetes is managed by the Cloud Native Computing Foundation, which is a vendor-neutral governance group for Kubernetes, but also many other cloud native technologies. And so now that we've kind of like given a little background, let's dive into the working definitions that we're going to have for Kubernetes and cloud native. And this is what I'm going to be trying to prove today. So when I say Kubernetes, we're going to say Kubernetes is the governor of cloud native IT. And business cloud native is cloud native technologies help businesses build modern software that delivers a good and or service to their customers. These technologies create better systems that allow engineers to make changes faster at a lower cost. So better, faster, cheaper. Here we go. So we're going to take a little step back and figure out how we got to cloud native IT. So where did we actually come from? And so the metaphor that I'm going to be making today is that we have a software application and we need to host it on a server. But remember, we're going to do this without code. So we need something that's explainable in the real world. And the metaphor I'm going to be using today is a person needs a house. So when you want to run a website or a cool machine learning job or blockchain, if that's still hot, you need to host that code on a server somewhere. Similarly, in the real world, you need a roof over your head. We need to host a person in a house. Okay? And the hosting continuum that we're going to go through is on the housing side, home construction, renting, apartment, flat share, to hotel. And on the data side, we're going to have data center, cloud, virtual machine, container, and serverless. Okay? And what we're going to find as we move from the left side to the right side, we're going to be moving towards better, faster, and cheaper. And we're going to describe that as simplicity, agility, and density. So as we move further to the right on the cloud native continuum, things get simpler, they get more agile, and they get denser. Okay, so first step, build your own. Build your own data center, home construction. Perfect. Okay, so I need a roof over my head. First thing I'm going to do is construct a house. So what does that look like? Well, first I need to find the land. I need to requisition all the materials. I need to start putting things together. This doesn't leave me a lot of time for free time, like contributing to open source projects or other fun things I want to do. Similarly with a data center. So you want to build a data center. Now you get to rack all the servers, plug them in, make sure there's actually electricity, all those fun things. But what building your own actually allows you to have is complete isolation. It's yours. You can decide however you want. Customization. If you want orange wires going in, or if you want purple ones, that's up to you. And you can complete control over how it's designed and built. So that's great. But there's also some problems with this. So it's not so good when you're running your own data center. And I don't know if anybody else saw this on Twitter, but I thought it was hilarious when a deer broke into a data center. that's your problem. This is your house or this is your data center. When that deer breaks in, it's now your problem to go fix it, even if it's at 3 a.m. Faster. The problem with building your own thing is it actually takes a long time. If I wanted to build my own house today, I'm probably looking at a roof over my head, maybe not 2 weeks, but maybe like a year down the road. Same thing with the data center. It's a really long lead time to actually be able to just host a simple website. The other thing is there's a lot of capital expenditure that goes up front. So when you want to build something yourself, you need to lay out all the money right away. So you need to pay people before you can even start hosting something to generate revenue. So how can we fix that? Next, we turn towards rental. So on the hosting side, you're going to see cloud. Cloud or managed hosting providers. And if you're thinking about this on the housing side, you're going to have a landlord. So it's no longer your house or your server, but it's somebody else's. It's somebody else's computer, there is no cloud, or it's somebody else's house, it's not yours. And so what advantages does this give us now? Well, it's a lot better because now that it's somebody else's problem, you get to sleep through that deer in the data center. Or say your water heater breaks, it's no longer your problem to go fix it. It's now the landlord's. And so instead of having to fix your water heater or fix a break-in, you can now go enjoy doing what you actually love to do. The other thing is it's a lot faster. Instead of having to build things all yourself, the managed hosting provider or the landlord already has built this for you, and it's more ready for you to move in. So now, if you want to have a new server, what it looks like is you could, with managed hosting providers, say you call them up or create a ticket, and they provide a new server for you to host that. So that may take a day or two, but it's a lot faster than having to build it yourself. And on the money side, you're moving from a capital expenditure model where you're putting all the money out front towards more operational expenditure. So you're only using things right when you pay for them. So I rent my apartment. I don't have to pay for building the whole house. I just pay on a monthly basis for using the actual space. It's a lot cheaper. Great. But there's still some problems with the rental. It's still like a very manual setup process. When I want to move into my apartment, I need to go rack it, stack it, and same thing with servers. Also, 2 days is still actually a long time. Say you suddenly just hit the front page of the newspaper, 2 days will be like you're already off the news cycle, like you missed your chance and your website was down. The other thing is it's not very cheap. So right now I'm in Stockholm, my apartment is in Berlin, I'm still paying for it even though I'm not there. So you have dedicated costs. You're saying you're renting it for a specified amount of time. So how can we improve on this situation? Well, the next thing we can do is creating a split space. So on the hosting side, this looks like virtual machines with our tools like Chef, Terraform, or Ansible. And on the hosting side, this looks like a furnished apartment. So it's great. When I moved here to Germany, I'm from the US, in case you couldn't tell by the accent. I didn't really have anything, so it's great that I could just move in. I could find an apartment that fit my size. It already had everything in it, so I didn't have to move over here with everything. It was set up for me, and it was just the size I needed to. And what you're saving here is instead of having to rent out a whole building, you can slice it into individual things, individual apartments, and it's a lot smaller. Same thing with a virtual machine. These tools help you automatically provision a machine that's right size for you. So I can go onto, let's say, AWS or GCP and provision a machine with whatever I want to. Okay, so great. So we're changing from a manual setup process to consistent deployments that are repeatable. I don't have to worry about forgetting a step when I'm moving into, or when I'm moving into an apartment. I don't have to worry about like, oh, I forgot my couch, or oh, I don't have a bed. It's there every single time. It's a lot faster when it's ready to move in, whether it's a server or an apartment. If it's furnished, everything is there for you and it's automatically done. Same thing with a virtual machine. They're automatically provisioned. It takes about 10 minutes to spin up. And the other thing is moving to cloud providers. Since they can spin virtual machines up and down so quickly, you're moving from this dedicated cost model towards a more per second billing. So a lot cheaper because you only have to pay for what you use. Wouldn't it be great if my apartment in Berlin, I could just not pay for today? Okay, that's great. but there's still a couple problems. We have these clashing dependencies. So right now with a furnished apartment, it kind of looks like a loft where everybody's like living in one big room. I really like biking. My roommate really likes gaming. His computer is loud. My bike trainer is loud. We kind of get in the way of each other. Same thing if you're trying to run two different versions of a software in the same virtual machine. There's some problems there. 10 minutes is still a long time. I mean, say you want to just test out one line of code change really quickly. How can you do that faster instead of just sitting around for 10 minutes? And that's what I was saying before. It's only kind of like single use. How can we use our space more efficiently? So in my apartment, I only use the kitchen for, say, like 30 minutes a day. Is there a better way to use that? And so we go into a more shared space model. So if you're looking at the housing side, this is a flat shore, a Vega, or I don't know, whatever country you're from. And so what you see there in a flat share is everybody has their own individual room, has their own space where they can kind of have all the activities set it up how they want without anybody else interfering. And then we can also share the common spaces. So I share my kitchen with my roommate. He cooks for part of the day, I cook for another part. We have higher usage, great. Same thing, what a container allows us to do is to have multiple applications sharing the same host OS. So they're sharing the same underlying system while still being separated from each other. And so what does this create? A better separation of dependencies. Everybody has their own room, has their own space, or each application has its own little place to run separate from each other. The other thing is it's a lot faster to spin up. Containers are way more, let's say, lightweight is the term. And so instead of 10 minutes, now you can spin them up in half a second. So you can scale things out a lot faster. The other thing is working with some of our customers. If we're working with virtual machines, we see some of them at like 15 is like kind of the best CPU utilization. In some banks, we've seen 1 or 2%, and we've seen that increase to 80%. So great, you're using your space a lot more efficiently because you can pack things in more densely. Okay, but there's still a problem with containers or with FlatShare. There's still some setup required. I can't just show up here today and have a FlatShare for me to stay. If I want to just be here for 2 nights, how does that work? That setup time, actually moving in and finding it, is costing me. And the thing is, it's always on. How do we turn that off? So when I come here for 2 days, I don't want to rent an apartment in Stockholm for the whole time just for this 2-day conference. How do I make that better? And so the way that we do that is through on-demand. So on the coding side, that looks like serverless, and on the housing side, that looks like a hotel. So when I showed up here last night, I checked into the hotel, everything was ready for me, and I'm checking out tomorrow night. And so it's perfect. I just have 2 days of use, and that's all I pay for. And so what do we get with on-demand infrastructure? Well, no setup is required. So with serverless, you don't need to worry about the servers. That's why they call it serverless. With a hotel, I just show up, and everything's there. It's faster because it's always ready. Everything's set up for you. You don't have to worry about setting things up beforehand. And the last part is cheaper because you just pay per execution. So I'm only paying for the 2 nights that I'm here. I don't pay for any other time. Same thing with serverless. Most cloud providers right now have a pay per execution model. So you're only paying for your exact usage rather than having any extra overheads. You're going from that 80% to, let's say, 100% usage. And so to kind of sum this all up, as we move from home construction or data centers on the left of our hosting continuum all the way to the right where we have hotels and serverless, at each step of the way, we've got more simple, more agile, more dense. So better, faster, and cheaper. Moving to the right creates a more cloud-native business. And what that allows us to do is to focus on providing business value and not on the infrastructure. Okay. So to sum it up, looking at our definition again, it seems like cloud native, these help create better systems that allow engineers to make faster changes at lower costs. That's the conclusion we've come to as the first part. And now, how do we get to Kubernetes? Where does that fit in? That's the other buzzword that we were talking about. And Kubernetes is the cloud-native operating system. So the great thing about enterprise IT is that you don't have a single software application, and you don't have a single server. You have hundreds, thousands, millions, or in the case of Google, you have billions of containers that need to be run. And so how do you do that, and how do you manage the workload across all of your servers? The same thing is, we're in Stockholm. It's not one person looking for one roof over their head. We have a whole city of people all looking for housing. So how do we match different needs of people to those housings? And as we were saying before, we were saying Kubernetes governs cloud-native IT, similar to a city governs the housing market. And so I'm going to now go back to our original definition of Kubernetes. I'm going to break this down into each part individually, and hopefully by the end of it, it'll make sense to me. Probably already makes sense to you. So Kubernetes is a portable, extensible, open source platform for managing workloads and services that facilitates both declarative configuration and automation. Great, so how do we break this up? And the way that we're going to do that is kind of going through each layer of our stack. So from Kubernetes to software applications, and from a governor all the way up to the people that we're hosting. And so we're going to start at the bottom with Kubernetes and our governor. OK, so governance. How do we do it? What's the best way to govern? And how do we make it fit our needs? How quickly can we build out a governance structure? And how quickly, when something breaks, can we respond to it? What's the most cost-effective way to build it? And how can we save human time? Because in most companies, that's actually the most expensive resource that you have. So Kubernetes does this through declarative configuration and automation. And so to kind of describe how it does that is we're actually going to go back to the definition of a problem. So a problem can be defined as any situation in which a gap is perceived to exist between what is and what should be. So if we look at this picture, what should be is we should actually have a bridge, and what is that we don't. There's a gap between those two things. And so how do we solve that problem? Well, if there's an actual state and a desired state, we can bring them together through a process called reconciliation. And this right here is the core of Kubernetes, the reconciliation process. And so Kubernetes does that through a scheduler and a controller. So a scheduler schedules resources. The controller checks to make sure what we're actually saying, how those resources should look like, actually looks like that. And it reconciles any difference between those two states. So we actually have a full and complete bridge. And so the way Kubernetes does that is whenever you want to make a change, you get to talk to the API server. The API server talks to etcd, which is the database that stores exactly how everything should be. And it tells the scheduler and the controller what's an etcd. And if there's any difference between those, we have a process called reconciliation. The same way in a city, your governance is I don't know, it's in America, it's a mayor, so that's what I call it here. You could talk to your local elected representative. They have a city plan, and there's that. Once that city plan is created, you can go talk to the builder, and there's a regulator. So one person builds it, the other person checks how it is, and if there's a difference, we get to reconcile the difference between those two. So our cloud native city, you can see both of these combined, they have similar roles. And so what does declarative configuration and automation allow us to have? It allows us to declare how we want something to be, and it reconciles any difference. It's a lot faster because, as we saw, it's automatic. You're replacing human time with computer time. Next part is land, or in the case of our cloud native stack, bare metal or any cloud provider, wherever you're actually going to be hosting your infrastructure. And so the questions here is how do we ensure quality and consistency of our compute? How fast can we build up our infrastructure, and how fast can we tear it down? And how can we make sure we're always paying the cheapest price? And so the way Kubernetes does that is by creating a portable platform for you. And so the core concept behind this in Kubernetes is Kubernetes nodes. That's where our software applications are actually hosted. A similar way, when you have a city, you have some land that the city is going to be constructed on. Okay. And so what does this portable platform allow us to do? It's a lot better because you have a consistent quality everywhere. You can host wherever you want, and it'll be the same. It's a lot faster because you don't need any retooling when you're moving across different infrastructure providers. So one of the things that we work on at Lutza is Cluster API, which is providing a consistent way to provision and manage machines across any infrastructure. It's open source. You can contribute to. That's like the open source pitch right now. And it's also cheaper because it's portable. You're not locked into one piece of land. You don't have to buy the land that's right next to the sea. If you need something cheaper, or if you want to move to a different cloud provider, the Kubernetes is a consistent experience across all of this. So moving up one more layer of the stack is we have our city services and our buildings actually on top of that. In a similar way, we have ways to manage VMs, containers, and serverless on Kubernetes. And so what these city services look like is, like, say, electricity, running water. How are those provided in a way that we don't have to worry about? And the cloud native stack is Kubernetes provides networking, the runtime, and the isolation for you. And so when you're trying to scale up services, how do we ensure quality and consistency and the right level of abstraction? How long does it take to switch contexts? And can we reduce that? And how can we have an overview of our costs, and how can we optimize that? And the way Kubernetes does it is managing workloads and services all together in one platform. And so as you have these different types of housing, they all need to have electricity, running water. The same thing on the Kubernetes side, you have VMs, containers, serverless. How do you manage all of them? And Kubernetes provides a platform to manage all of them together in one space. It provides abstractions and consistency across any type of application you want to host. You don't have to worry about context switching. You don't have to switch from one platform to the other. This is a lot faster. And it's cheaper because you're consolidating all of your infrastructure into one place. And finally, we have the fun part. We get to host our software applications, and we get to have our people on top now. And so when these people actually move in, what happens next? That's really the question. What else is needed beyond just a server and a software applications? How can we customize it to fit our business needs? What new functionality is delivered? And how can we decide where to best spend our money? Should we build something, or should we buy something? And the way that Kubernetes solves that is extensible and open source. And so if you look at the CNCF landscape, there's a lot of different things that you can plug into Kubernetes. Some of these are open source projects. Other of these are specific vendor products. But you can choose whatever you want to. And so in a similar city, not every city will need a shopping mall, hospital, church, university. Each city has its own requirements about what it needs. In the same way, each business and their IT department has different requirements around what they need and what scale they're at. So most companies will need CI/CD, just like most cities will have a shopping mall, but maybe not every department needs to work on streaming or messaging with like gRPC, and maybe not every city has an Opera. It's really up to you to decide and customize Kubernetes to your needs. And so that provides you the choice and flexibility to have the infrastructure exactly as you need. You don't have to wait for a vendor to create something. It's an open source community, so if you want something fixed, you can go and do that. And you get to decide whether you want to build something or whether you want to buy something. And you get to decide what is your business core competency and what's not. And so now, going back to our definition in each part that we did, so Kubernetes is a portable, extensible, open source platform for managing workloads and services that facilitates both declarative configuration and automation. And what is IT for business? So Kubernetes is the cloud-native operating system that allows engineers to create better systems. We can make changes faster at lower costs. This enables businesses to deliver better value to customers more quickly and less expensively. And so thank you for coming today. I'd like to say thanks to DevOps Gathering for hosting me. Thanks from a company for keeping me employed for a little bit longer. Especially thanks to Nikita and Tobias for reviewing this talk with me. Cho-Heng from the CNCF also gave some of the ideas behind this. And I'd also like to thank my mom for listening to me a whole bunch of times practice this talk. So I work for Ludsa. Since this is a tech talk, I'm gonna, I always have to say, we're hiring. This is also a business talk, so we're also selling. If you want to talk to me, you can either contact me on Twitter or at my email. So thank you. Any questions?
Yeah. Nice talk. Thanks. Yep. I now understand Kubernetes finally. So, yeah. What I want, has anyone questions to Bo? No question at all? Ah, okay. doing a little workout.
Yeah, thanks for the nice analogy. How would you explain Kubernetes for the developer, but the non-infrastructure? Because you explained it to the non-coder, so really another level of abstraction. But for the Java dev who barely knows how to build a WAR file.
That's my next talk. Come next year.
This is a good idea.
I think the same analogy kind of works. Is just like the dev should think of themselves or their piece of software as that person, and how can I host it? How can I find the housing that fits my needs? So the devs don't want to have to worry about a lot of these problems. And as we saw, as we move further to the right, there's less. It simplifies the process for them.
So, are there more questions? No? Is it enough for you, as for your Java developer that can't build
There's
a
one more.
But
Sorry.
probably you shouldn't
One
make
more.
make draw.
Here's one more.
Oh, sorry.
So did you actually present this to business people also?
I've not yet, to be honest. So I'd love to have your feedback on what you thought it was.
Oh.
Hi. I like the analogy to the hotel because you have everything supplied for yourself, but also you have to consider like what it costs to live in a hotel if you're living there for a longer time. So you have to make considerations. If you're using like the big cloud providers, sometimes it can be cheaper to host the infrastructure yourself. And I would like to know if you have some recommendations for like when you want to get into Kubernetes and not like start on the big cloud providers. What's an easy way to start? Are there small providers managed Kubernetes, or how do you suggest, or should we jump right into Azure and AWS and everything?
Okay, this is like biased. I mean, I work for a company. So definitely, if you want like a very easy Kubernetes experience, like GKE, so Google Kubernetes Engine is like well known as like the simplest way to click. There's a cluster. So our product Kubernetes provides the same experience, so a GKE-like experience on any infrastructure. There's Sys11 is like one of our customers, and we provide a white label solution that provides you one-click Kubernetes if you want to start with a smaller hosting provider. I think what we're seeing in the industry is like Kubernetes should be boring. And it shouldn't be what you should focus on. Most people say you should go with some managed experience because there's a lot more interesting things and a lot more value you can provide on top. Kind of going back to the slide I said before, you want to focus on your business value. You don't want to focus on the infrastructure. And a managed service helps you able to do that. Choosing the right one is like an individual choice. That's up to you. I can certainly help you, but I'm also biased.
So, has anyone also a question regarding running cloud or using Kubernetes? No. Okay. So, thanks, Bill, for your talk. We will make a short swap.
One more question.
Okay.
Yeah.
You should decide earlier. So your decision is a bit too late, or my reconciliation loop is too.
Now, also thanks for the talk. You have given me some interesting points to talk about with management. One usual question is, that I've already gotten is, are we prepared to live in a hotel? What do we have to do to actually, I don't know, just to stretch the analogy, pack our bags and then live there? What do you suggest I might answer to that?
So is this asking about readiness?
Yeah, how do I check if I'm ready or if our organization is ready? What do I have to do in order to actually make use of a hotel instead of my own house?
Yeah. So it depends on like where you're actually starting from. So whether you're starting with like Fortran code or if you're starting with Rust, there's a difference there, and how basically ready your applications are for a cloud native world. So there's actually some open source tools from Red Hat where if it basically checks like if your Java application, what parts of it will be easiest to move towards a container environment or towards a serverless environment, and gives you basically, these are the easiest ones to move first. And so there are tools to help you be able to do that. We can also talk afterwards if you want.
Yeah, so I think no more questions in the room, right?